Welcome back to Ava Consulting. Today, we're breaking down the analyze phase of the DMAIC process. This is where raw data transforms into actionable insights. We'll show you how to uncover root causes, validate assumptions, and pave the way for meaningful improvements. The analyze phase is where the detective work begins. This step is all about understanding why defects or variations occur. By applying tools like root cause analysis, statistical tests, and visual data mapping, we can identify the exact causes of a problem. The goal here is to focus on the factors that drive performance variations and inefficiencies. To uncover root causes and validate assumptions, the analyze phase relies on a range of key tools. Let's take a closer look at the most important ones. First, we have the Pareto chart. This tool is based on the 80-20 principle, which tells us that 80% of problems are typically caused by just 20% of the factors. A Pareto chart is a bar graph that organizes causes of defects from the most frequent to the least frequent, helping us prioritize where to focus improvement efforts. The chart also includes a cumulative percentage line, which makes it easier to see which issues are contributing the most to the overall problem. By identifying the small number of factors causing the majority of the issues, we can address the biggest contributors first, leading to more efficient problem solving. Next, we have the Fishbone Diagram, also known as the Ishikawa diagram or cause and effect diagram. This tool helps us identify all potential causes of a problem by categorizing them into broad areas like manpower, methods, machines, materials, measurements, and environment. The diagram is structured like a fish's skeleton, with the problem at the head and the different categories branching out like bones. By systematically listing all the potential causes under each category, the Fishbone Diagram ensures that no stone is left unturned in the search for root causes. It's particularly helpful for visualizing complex problems that may have multiple contributing factors. Hypothesis testing is another essential tool in the analyze phase. This statistical method is used to validate assumptions and determine whether a particular factor is actually impacting the process. Here's how it works. We start with a null hypothesis. This is the assumption that there is no significant effect or difference caused by the factor in question. We then collect data and use a statistical test, like a t-test or chi-square test, to check whether the data supports or rejects the null hypothesis. This is especially useful when you want to ensure that any changes you're making to a process are backed by statistical evidence, rather than random chance. It gives you confidence that improvements will lead to measurable results. Regression analysis is a tool used to understand the relationship between different variables in a process. It helps you quantify how changes in one variable affect another, allowing you to predict outcomes based on input adjustments. For instance, in a manufacturing setting, you might use regression analysis to see how changes in machine speed affect the defect rate. The results are often displayed as a scatter plot, where each point represents a data pair, and the trend line shows the strength and direction of the relationship between the variables. This tool is invaluable for making informed decisions about process adjustments, as it provides a clear understanding of cause and effect relationships within the data. Lastly, we have process mapping, which provides a detailed visual representation of the entire workflow. A process map breaks down every step in a process, showing how each task flows into the next. This tool is particularly helpful for identifying bottlenecks, delays, or inefficiencies that might be causing issues. Different symbols represent different types of activities, for example, rectangles for tasks, diamonds for decisions, and arrows for the flow of work. By visually mapping out each part of the process, you can quickly spot areas that need improvement, making it easier to streamline operations and reduce waste. The analyze phase can come with its own set of challenges. Teams may encounter data overload, where too much information makes it difficult to see the root causes clearly. It's also common to fall into analysis paralysis, where the process of analyzing becomes so detailed that it prevents timely decision-making. To avoid these pitfalls, focus on the most impactful data and use tools like hypothesis testing to validate findings. By staying data-driven and focused, you can uncover the true causes of variation and defects. That wraps up the analyze phase of our Six Sigma guide. The analyze phase is where we turn data into insights, setting the stage for meaningful improvements in the next phase, improve. If you found this breakdown helpful, be sure to subscribe to Ava Consulting for more Six Sigma insights. Don't forget to like and share this video. Let's continue building excellence, one process at a time.